Types of chemical reactions. I'm just learning this, so I typed this up on the weekend, but I haven't memorized it yet either. You know I haven't memorized it yet when I have to refer to the notes. Who has me for math? You'll notice for math I can wander around and teach off the top of my head. I can't quite do that yet in science. Next year. So flunk and I'll be better next year. There are a number between 5 and 7. How many? 6 types of reactions we're going to learn about. The first type is what we call a synthesis reaction. That is the joining of 2 elements. Two people call each other, they fall in love, they start going out. A couple forms. Sodium joins chloride. They synthesize into sodium chloride. So a synthesis is when we put 2 elements together. Decomposition is the opposite of synthesis. That's when you take 2 elements and what do you think? If it's the opposite, what do you think decomposing would mean?
Get rid of?
Not quite get rid of, breaking apart.
Break down.
Break down a compound into elements. The third type is called a single replacement. In a single replacement, one element in the compound is replaced. In a single replacement, one element in the compound is replaced. So for example, if I was doing a single replacement reaction and U4 were the compound, a single replacement would be me saying, I can't stand Amy anymore, bumping Amy out, putting Justice in there, single replacement. Everything else stays the same. And Amy would be by herself. Then we have a double replacement. This is when 2 compounds trade partners. In fact, it's very, very similar to what went on in neutralization, which we'll talk about a bit more. A double replacement. Sorry for my messy handwriting. So let's suppose Justine and Josh are a compound, and let's suppose Curtis and Miller are a compound. A double replacement would be swapping Josh and Curtis. Jake, I said Josh. Swapping Jake and Curtis. Good Josh. Okay? You guys would stay, trade partners, double replacement. We've replaced 2 things. How many is that? Uno, dos, tres. That's 4. The 5th one, we looked at this last unit, but we were looking at it in more detail this unit. What's called a neutralization reaction. This is when you combined an acid and a base, because an acid had a pH below 7, a base had a pH above 7. When you combine them together, the upper and lower pH cancel each other out. The fancy word for cancel each other out is a word that begins with the letter N and rhymes with neutralization. Neutralization. We say they neutralize. They become closer and closer to a pH of 7, which was in the middle. Acid and base form water. The H from the front of the acid and the OH from the end of the base became HOH or H2O. And does anybody remember when you combined an acid and a base, what was formed? Water and what? Salt. That's where a salt was defined as. Not just what you put on your food. The very last one is the one most of you think as the funnest. Combustion, not explosion, although explosions, some types of explosions, if they involve some kind of a hydrocarbon fuel, are combustion. That's when you take a hydrocarbon. Oh, what two elements were in a hydrocarbon? Okay, if you take some like CH4, that was methane, that was the simplest one, some kind of a hydrocarbon, and you burn it in, what do you need to burn something?
Oxygen.
You need water to burn something? Really? Wow. Okay. Fuel, so the hydrocarbon. What's the second one? You said it.
Oxygen.
Except we're going to say O2 because oxygen is Mr. Hofbrinkel. It always comes in pairs when it's by itself. O2, yeah. Hydrocarbon, you burn it in oxygen, and what you get is water and carbon dioxide. You get some water condensation, and you get carbon dioxide. What do most of our cars run on? Hydrocarbons. What do most of our cars produce? Carbon dioxide. That's the greenhouse gas. In low levels, not too big a deal. For thousands and thousands of years, we've used fuels, woods, we've used combustions, really, to run almost everything, to cook our food, steam plants, all that stuff back then. Now we're using it a little too much. So let's look at these. Those are the 6. Let's look at these in more detail. And the way we're going to kind of remember these is to use a generic pattern and see how it mixes and matches. So the first one is a synthesis. 2 or more, but usually in science 10, 2 reactants combine to form a single product. Hayden, could you stand up, please? Amber, could you stand up, please? So here are our 2 reactants. If we have a synthesis reaction, we suddenly have this come together, link arms, and we have Amberden, or Haidmer, or whatever we wanted to call it. There's our combined reaction that you guys can see. Okay. If I wanted to write that generically, Jessica, I would say you have element A plus element B. We put them together, they form element AB. That's our generic version of the synthesis reaction. Now, I have an advantage. I know what the word synthesize or synthesis, I can't say it, but I know the definition. Synthesis means. It means to join together. So if you know that word, you're lucky because it kind of makes sense for the name of this. It's not really an English 10 word. You may not know the word. Sorry. As an example, you can combine, hey, what is Na? What is Cl? Oh, but Cl is part of Mr. Hofbrinkel, which is why I wrote Cl2. What do they oh, you know what? We need our pink sheets. We need our periodic tables out today. So if you want to get your pink sheet, your periodic table out, unless you have it memorized, and no one sung the periodic table song for me yet, so I don't think anyone has it memorized. Mr. Duick, would you give bonus marks if we sang the song? Yeah, probably. Okay, got your pink sheet? Okay, sodium and chlorine are going to combine. To figure out what they form, I have to crisscross. So over here, off on the right, Hayden, my friend, I'll write sodium, I'll write chlorine. This is my rough work. What's the valence charge on sodium? Find it on your periodic table. What does it say in the top right corner of sodium? 1, positive. What does it say in the top right corner of Cl? -1. Oh, so when I crisscross, I'll get a 1 there and a 1. Am I going to write the ones? You know what? They form NaCl, sodium chloride. Oh, and then what did I write next to the arrow with a big exclamation mark? It's in front of you. You have to look down. It's off my screen. What did I write next to the arrow with the big exclamation? What did I write right here?
Balance.
Balance this. It's the whole thing in front of you. I can't fit it on the screen right. Balance this. Okay, first of all, this is sodium, and then we use our ide rule, chloride, table salt. Is this balanced? Yoink. Sodium chloride. Okay. Is this balanced? And how do I know? Okay, there's 2 chlorides in one. Let's see if we can do this showing no work just on the fly. So how many chlorides do I have on the left? Count them. How many do I have on the right? How can I fix that? Okay, let's put a 2 right here. What problem does that create? How many sodiums do I now have on the right, Justine? 2. How many do I have on the left? How can I fix that? Oh, put a 2 right there, and I think we're balanced. If you're at the stage for the nice, reasonably straightforward balancing equations that, Alon, you can just do it, great. Okay. If not, you can still do my little divide it in half, write out how many, and start working your way across. And that's fine, too. That'll get you there all the time. But I've seen a few of you saying, hey, Mr. Duke, I'm just kind of doing these in my head. Great. That's the eventual goal anyways. N2 plus O2. What will they form? Well, first of all, this is a synthesis reaction. How can I tell? This is really A plus B. It's going to form AB. N and O. No, the elements. What's the charge on nitrogen?
3.
What's the charge on oxygen? 2. I think they're both -3 and -2 technically. But crisscross, we need, yoink, 3 of those, 2 of those. It's going to form N2O3. Let's see here. Now I'm looking at my notes, and in my notes I wrote N2O. Why did I write N2O in my notes and not N2O3? Think, Mr. Dewick. Bear with me while I look this up. This is what happens. Prepare your own, chapter 5. Synthesis. Okay. I'm going to tell you that this forms that. So cross out the 3. We're not going to use the crisscross rule. I stole this from the textbook. This is actually something called, it's a covalent. How many nitrogens? 2. How many oxygens? So we would call this dinitrogen monoxide. Let me push that up a little bit, Mr. Dewick. How about dinitrogen monoxide? And this is a special, you know what? It's not an actually, it's a polyatomic ion. That's why it's not crisscrossed. You know what this is? This is nitrous oxide. This is laughing gas. So you may have heard of some. The dentists used to use this as an anesthetic. If we balance this, so here's my final product. I didn't know that it was going to be N2O. If we balance this, well, let's see. What do we need? Put a 2 here. That gives me 2 oxygens and 4 nitrogens. Here I have 2 oxygens and, 4 nitrogens. So part of your homework, part 1, is going to be the practice problems. They are from page 259. I copied them right to here. You can find the answers in the back on page 592. That's going to be homework part 1. I'll give you time to work on these in a little bit, but if you'd be so kind as to turn the page. Decomposition is the opposite of synthesis. It's the opposite of synthesis. This is when you break down a compound into either Smaller compounds or single elements? Haidmer becomes Hayden and Amber once again. Okay. AB becomes A plus B. Okay. So NaCl would become Na plus Cl, except I got to put two Cl's because Mr. Hofbrinkel says chlorine is diatomic. When it's by itself, it automatically forms pairs. Now the question, Dylan, is, well, how would you split apart? So there's all sorts of different ways to cause chemicals to decompose. There's electrolysis, you can mix it with something, there's lots. But we're just going to imagine that somehow it happened naturally, spontaneously. Is this balanced? How many chlorines on the right? I need 2 over here then. Oop, how many sodiums did I just pick up now on the left, Sarah? So I better put a 2 over here, and I think now it is balanced. And for some reason I made that A look like a subscript. Let's put it on the same line right there. A very common one, Hayden, is water. We break water apart, and when water breaks apart, it breaks up into not H and oxygen. Hydrogen is diatomic. Oxygen is diatomic. It breaks up into H2 and O2. This is what we're doing with a fuel cell. We're hoping this might be one of our future power sources. One of our future power sources, a fuel cell, is you add water in, and at the other end you get oxygen and hydrogen. You burn the hydrogen for your gas. The oxygen goes back into the air. We're okay with oxygen going into the air. And you get a bit of water vapor left over as well, but no carbon dioxide. The problem right now is most fuel cells at this point either take more energy in than you get out, or the ones that we do get more energy out, they're really, 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 really finicky. So there are a couple of buses that run on fuel cells, but they are in the shop a fair bit. Having said that, do we have a shortage of water here on the Earth? No, we got oceans full of it. This might be one of our future powers. Balanced? Let's see. I got 2 oxygens on the right, so I need 2 on the left. Oh, but Hayden, how many hydrogens do I now have on the left? Can you see it?
2.
I got a 4. How many do I have on the right?
2.
How can I make that vote? Are you saying put a 2 right there? Yes. I think now that's balanced, yeah? Oh, you need to know the diatomic elements. And the word I gave you was Hofbrinkel, which stands for hydrogen. If it's by itself, it's always going to be an H2. Oxygen, if it's by itself, it's always going to be an O2. Fluorine, if it's by itself, it's always going to be an F2. Bromine, if it's by itself, it's always going to be a Bro2. Iodine, if it's by itself, it's going to be an I2. Nitrogen, if it's by itself, it's going to be an N2. Chlorine, if it's by itself, it's going to be a Cl2. You may notice that the halogens on your periodic table, fluorine, chlorine, iodine, bromine, those are Hofbrinkels. And then you have nitrogen, oxygen, and hydrogen. So part of your homework is going to be the practice problems on page 70. This is gold chloride. It would break up into gold and chlorine. This would break up into potassium and O2. Oh, and by the way, it would break up into Cl2, and then see if you can balance it.
And then we just write 2A.
Oh, 2A has also got some homework. There it's just asking you to identify it as a synthesis, decomposition, or neither. Probably going to do 2 more today, and then we'll pause. Single replacement. Single replacement. This is a single element plus 1 compound. Okay? Single element. One element bumps one element out of the compound. And you can even figure out which one will bump what. A metal will bump a metal? What do you think a non-metal will bump? A non-metal. Okay. As my generic pattern, what we're saying, Emily, is if you have a single element plus a compound, the A will bump the B out, and AC will be together, and B will be by itself. That's if both A and B are metals. If both A and B are non-metals, then the non-metals will bump each other out. Give you an example. We have aluminum all by itself. We have, what's Cu?
Copper.
And Cl? We have copper chloride. The one by itself is aluminum. Aluminum, metal or non-metal? It's going to bump the metal. What we're going to end up with is AlCl and Cu. Except with the AlCl, with our new compound, we need to crisscross. Let's do that over here. What's the charge on Al, aluminum? What's the charge on Cl, chlorine? 1. So when I crisscross, I'm going to get 1. I'm going to get 3 of those. Now I wrote balance this. This one might be a little bit trickier. Where do you think we should start out with? You don't have to write copper's charge in the actual equation. You would need it if you were trying to do something with it. Okay. Where do you think I should start balancing this puppy? Sorry? With ALs? There's 1 and 1. I don't think it's going to help me much. Oh, did you say the CLs? I'm sorry. Yeah, with the chlorines. Okay. Brendan, how many chlorines on the right-hand side? On the right, on this side, how many chlorines are there? Yeah. Huh? How many on the left? What number do those have in common? 6. You know what? Let's try putting a 2 there and a 3 there. That would give me 6 and 6. Put a 2 in front of the AL? Oh, because you're saying now I have 2 ALs. Put a 2 there. Okay. Oh, and a 3 in front of the CU? So you can sort of do these on the fly. Would I do them this fast on a test? Probably not. Would I try and do them this fast on the homework and then check my answer to see if I'd done it right? Sure, I want to get good at this. Absolutely. F2 plus NaI. That's not an L, that's an I. Okay. What's our single solitary element sitting by itself? Fluorine. Metal or non-metal? So which one is it going to bump? Metal or non-metal? So it's going to bump the I. Don't write that in. That's going to mess up our drawing. So I'm going to get this. The Na is going to combine with the fluorine, and I'll have an I by itself, except I is part of Mr. Hofbrinkel, so it's going to be an I2. Oh, let's crisscross NaF to make sure that the subscripts are right. Off in the margin, what's the charge on Na? 1. What's the charge on fluorine? 1. Oh, this one's going to work out nice. This one crisscrosses into 1 and 1. Are we balanced? No? Okay. Where might I start? Sodium? I think I might start with the I's. How many iodines on the right? 2. How many on the left? 1. Let's try putting a 2 there. Oh, and then put a 2 over here to make 2 and 2 sodiums. Oh, and that gives me 2 irons, and I had 2 iron. Hey! Balanced. Okay. Balanced. So, practice problems. Now, you can do the practice problems right in the notes if you want to, or you can do the practice problems on a separate piece of paper if you want to, but you need to open your textbooks up, first of all, to page 259, please. Page 259. Page 259, page 259. Okay. On page 259, number 1 is simply saying, complete and balance the following synthesis combination reactions. So the Mg and the magnesium and the nitrogen are going to combine. Make sure you crisscross properly, then balance. The aluminum and the fluorine are going to combine. Make sure you crisscross properly, then balance. The potassium and the oxygen are going to combine. Make sure you crisscross properly, then balance. Oh, the same for D, the same for E. Then in number 2, all it's saying is identify whether each of the following is a synthesis combination reaction. What you're really looking at the equation. Is it two things combining to form one single thing? Then it's a synthesis reaction. If it's something else, it's not. Turn the page, please. Looking at page 260, which in your notes I put right here. Okay. Number 1, all it's saying is complete and balance the following decomposition reactions. So these things will break apart. Remember when they're breaking apart, Brendan, to their constituent parts? That's where the Hofbrinkel rule really becomes important. That's when you need to say, oh, I may have had a single hydrogen on the left, but it's going to be an H2, or it's going to be an O2, or it's going to be an N2, or an I2. Okay? And then balance. And then number 2 is simply saying identify each reaction as a synthesis. How about S for synthesis? Decomposition. How about D or decomposition? Or neither. See if you can figure that out. And the answers are on page 592 if you get stuck. Then, next page over. You don't need to turn the page. Page 261. You can try. These are single replacement reactions. The metal will bump the metal, or the non-metal will bump the non-metal. So in this case, I think lead is the metal, aluminum will bump it, and you'll get aluminum chloride plus lead, crisscross and balance. Crisscross and balance, crisscross and balance, crisscross and balance. Then number 2 is saying classify each reaction as a synthesis, a decomposition, or a single replacement reaction. We're going to pause here. When I see you folks next, when do I see you folks next? So I don't see you for an entire week. You have a long weekend? Yeah, the headphone shouldn't be in your ear there, kiddo. Okay. No, sorry. Come to school on Monday at 8:30, please. There is school on Monday. Absolutely. Absolutely. No. School on Monday. Absolutely, there's school on Monday. Absolutely. Okay. Okay. So try that. We will pick up with this. So don't hand this in, folks. Don't hand this in. You're going to hand this in when you actually hand in the rest of your notes when we finish off this lesson. You should be able to finish off your homework and any other missing NHIs or any glitches that I made when I typed in your grade. I'm trying hard not to give you any homework for the long weekend, is my goal.